me walk through problem statement. So the problem statement says you will be given a matrix. It has couple of values. From each row, you can pick at least at max one value. So you need to pick one value from each row. So if you pick 111, so there will be three values, right? And you will also given target. So we need to return absolute minimal difference. For example, if you see, if I select these three values, right? So what is the value? It is 13. Target is also 13, right? So 13 minus 13, 0. So output is 0. Do you understand what I said? So you will be given a matrix. Let me explain. So you'll be given an m by n matrix. So let's say you have values 1, 2, 3, 4, 5, 6, 7, 8, 9. This is your m by n matrix. And it is 0, 1, 2, 0, 1, 2. And you're also given target, which is 13. So you are allowed to choose one value from each row. For example, if I choose one here, okay, so if I choose one here, then I can choose any one of the value. Let's say I choose 4 from here, then I choose 7 from here. Then what is the total value? 7 plus it is 12. Then for example, if I choose 1 here, then 5 here, then 7 here, then total value is what? 13. So in any direction, I'm just taking 1 here, 6 here, then 7, so which is about 14. Again, I can have 1, 4, 8, then 1, 1, 4, 8, and 1, 4, 9. Then, yeah, that's how you can do it. So you can repeat the same with other things also. Once after doing all these things, you will find sum of all the values, right? So we need to return minimum absolute difference. So here the target is 13, right? So here also thumb is 13. So 13 minus 13, which is equal to 0. So the minimum absolute difference is 0. So for example, here somewhat you understood, right? So now let's see how do you solve it, right? So simple. Uh, these kind of things, right? So this is how you should think about it. Let's take 3 by 2 matrix. So you have 1, 2, 3, 4, 5, 6. Okay. So from each row you can pick at max one value. So this is row 0, row 1, row 2, column 0, column 1. So let me give target as 9. 9 or what can I give? Okay. Let's give target as 11. If I get 11, 11 also I have the data. Okay, so let's give target as 11. So what is the minimum absolute reference you can find here? So that you don't know, right? So this is how you should do it. So let me uh, crop. How do you crop? Okay, this is the data you have, right? So let's move on. Uh, we will start from each row, right? So initially, so you'll go row and the current sum. Okay, so this is my recursive method. This is how my recursive method looks like. So uh, from each row, you can pick up any column, right? So for example, I start from row 0, so initial sum is 0. Okay, I start from row 0, initial sum is 0. I can pick up any column. So I can pick up column 0 or column 1. Correct? Correct or not? So I can pick up C1 or C0, C0 or C1. So if I pick up C0, so what is the value I have C at C0? 1, right? So it means it means if you want to make it more clear way, so this is how it is, right? So you have row number, column number, and the sum. Okay. So initially, so this is 3 by 2 matrix, right? So this is 3 by 2 matrix. Oh God. Oh, let me copy from here. Yeah. So this is 3 by 2 matrix. So you can pick up any column. So you have a choice of picking the column and on the specific row. Then that's how it move on. So let's pick up row 0. So first let's go with one by one. So you are at row 0. Okay. So at row 0 I can pick up 1 or 2. So if you pick up either 1 or 2, so this is column, right? So C1 or C2. So doesn't matter. So it means you are picking up from row 0, you can pick up either C1, so it becomes 0 comma C1, it becomes 0 comma C2. Correct? Correct, nobody? This is clear, right? On row 0, I can pick up any column. Uh, I'm very bad in writing diagrams. So 0 comma C1 means 0 and 0 comma 1. So this is C2 and this is C1 and this is row. Okay, perfect. So now if I pick up, let's move further. So we will explore further more. So we will see what are the possible values we could get. So from here, and you'll also get now. If I choose this one, then I can move on to the next row. So I can move on to the next row. So let's move on. Okay, so I'm moving on to the next row. So that is row number one. So in row number one, again I have same possibility. So I can pick up 1 comma 0 or 1 comma 1. So if I choose this, I can move on to row number 2. So if I move on to row number 2, it is going to be 2 comma 0 or 2 comma 1. Done. So if I move further, so there is no scope. So if I move on to next index, next index, definitely it is going to be 3, right? So definitely it is going to be, this is also row number 3, this is also row number 3. Similarly here also you will pick up 2, you will go on to 2. So again 2 comma 0 and 2 comma 1, then again you will move on to the next row, which is 3. So 3 is out of the scope, so you reach the base case, we will derive it. Similarly, let me do for this. So if you pick up row 0 C1, then you will have column 0 column row 1. Okay, let's move on. Then what you do, so you will move on to row 1. So this will remain same, right? So let me copy paste. Where is the difference will come in? So do you understand the recursion tree? Do you understand the recursion tree? Where do you see the difference will come, right? So where do you see the difference will come? So let's think about it. Both the trees remain same, look same, right? How do you see the difference? Now let's look at, yeah, the sum is the difference, right? So now let's understand. So initially I am at zeroth row and with zero sum. Okay, this is sum. Uh, So here my sum is 0. Now let's come here. So once I choose an 1 here. Okay, so row 0 0 0 means this one. So 1 here. So if I choose an 1 here, the sum becomes 1 here. Now when you come down, then you can choose 1 0. So if you choose 1 0, sum becomes 4. If you choose 1 1, sum becomes 4 plus the parent one, so which is going to be 5. Hope you are following me, right, Kalyan? We need to add it, right? So sum becomes 5. So similarly, if you come here, if you go to 2, so 5, 6, if you add 5 here, so it becomes sum becomes 9. If you add 6 here, then 6, right? So sum becomes 10. Now, when you go to third row number 3, right? So you are reaching out of it means you pick up in each direction you are picking up. So let me add all the sums, then we will come up to this. Then here 2, right? So 2 0 means this is 5. So 5 plus 5, which is 10. Okay. So here you got value 10 and 2 1. So 5 plus 6 means 11 because 11. So here what is the sum value? 0 1 means you go with 2. Then 1 0 means 2 plus 3, which is 5. 2 plus 4, which is 6. Then you move here. 2 0 means 5 plus 5, which is 10. And 2 1 means 6. 5 plus 6, which is 11. And when you come here, 6 plus 5, which is 11. 6 plus 6, which is 12. So this is clear, right? So we were able to derive all the sums in all directions, right? Correct? Now, when you reach the base case, right? So when you reach the base case, what is your job? So this is your base case, right? So when you reach, whenever your row number is equal to nums dot length, you are reaching the base case. So once you reach the base case, what is your job? Find the absolute difference between these two. So it means you are choosing one path, right? Yes or no? So you are choosing this path and you got the sum, right? Sum as 9, and you are also having target. So find the absolute difference between them. So definitely the target was 11, right? So 11 minus 9. So generally 11 minus 9, so which is equal to. So here 11 minus 10, 11 minus 10, which is equal to 1. And 11 minus 10, which is also 1. 11 minus 11, which is 0. Here also 1, which is 0, and which is also 0, and which is 2, which is 1. Absolute difference. Okay, 11 minus 12 means definitely it is plus 1 only. You consider my absolute difference, and you figure out all the sums. Somewhere you found value as 0. So this is the minimal sum, right? Yes or nobody? So you just need to return that minimum sum. Understood? So, okay. Now, now tell me, how do you solve it? What is the time complexity? Tell me. This here n is right. So n is like it is column length, right? Yes or no? If you have 3 by 6, then you will have 6 directions, right? Here you have C1, C2. Hmm. Is it m into n? So, so let's see this way. So if you pick up any cell, doesn't matter. Let's pick up a cell. Let's say m equals 6 by 6. How does it work? So 6 is, this 6 is okay, 6 by 7. Let's say 6 by 7. This 6 is representing what? Row. This is 6 is representing column, right? So then what are you doing now? So you for each row you are trying to explore all possible columns, right? For each row you are trying to explore all possible columns. It means for each cell you are trying to explore all possible columns, right? So this is cell only, na? So 0001 is a cell, right? So the number of cells you have what? M by n, right? m by n cells, and for each cell you are trying to explore possible columns. Column length we are trying to call it as n. So big O of m by n to the power n. Correct? Or is it correct or wrong? Let me think. No, again, this is another row, right? This is row 1, this is row 2, this is row 3, right? You are getting into each row. Mm, no, for each row we are just looking at. Okay, let me spend some time on it. Probably this is little tricky to handle. First, we need to understand definitely. Okay, so let me spend some time on it. So I'll come back on it. What is the space complexity? So it is m cross n, right? So at max you can have at max how many things we have? This is, let's say this is one, this is two, this is three. Is it m cross n or something else? Can you guess? Is it m cross n or some other thing? What is the max stack frame size you could see? Can I say it is big O of max of m comma n? Or you can say it's not max of m comma n also. It is big O of m only. M is nothing but row numbers, right? So you will maintain from each row you pick up only one value at a time. So that obviously you will end up having m stack frames, not more than that. So when it comes to time complexity, you have a row and you pick up all the columns and row all the columns. So definitely it is m into n. Then because for each row, whatever cell you have, you pick up next all the columns, and you are going exponentially. I'm thinking it is m into n to the power n. So let me come back on this. Okay, so what is the base case? Tell me. What is the base case? So when row is equivalent to, yeah, so which means m, right? So m is row length, n is column length. Okay. So when row is equal to m, then what we should do? So find absolute difference, then return, right? And what is then what we should do? So we need to have an optimistic result, right? So we need to hold that value. Okay, somewhere we will keep optimistic result. Okay, I think this will address it. So let's move on. So okay, find absolute difference. So how is it working? So you will have row and you will have okay, so you will have row and you will have current sum, and this is my target. Okay, so I don't think we need to derive the column. Column we can derive in the bottom. So how do you do it? So whenever you see that, if your row which is equal to, and you need this matrix, so you need this matrix. So whenever your row becomes matrix dot length, then you find, then it's time to return uh, math dot absolute difference of sum minus target. Correct, na? So now let's move on. Now, if it is not the case, if it is not the case, what you do, you need to explore all the columns for a given row, right? So what you do, so you will have column starting from 0 and column less than matrix of 0 dot length and column plus plus. Okay. So then what is your job now? So you need to explore. First you will add sum plus equal to matrix of okay, so I can directly do that. So what I can do, so find absolute difference. If you add it again, you need to backtrack and subtract it. So I don't want to do that. So on the same row, so you will move on to the next row and you will add the current cell matrix of row column. Then you will move on to the target and you will move on to the matrix. And this is going to return some difference. Okay, so absolute difference. Now, what is your job? What is your job? So we need to see that if you closely see, closely observe, buddy. If you closely see from a same row, if you closely see, this is my same row. Okay, let me share my screen. So this is my same row. In the same row, when I choose this direction, I got the min value. When I choose this direction, I got the min values. It means in the same row, so in the same row, row 0, 1, 1 and 2, 1. So which is returning the minimum value. So that is what the absolute difference giving, right? So that so when I'm in current row, okay, this is my current row. So when I'm in current row, let's take min equal to integer dot max value. Then whatever absolute difference you get, so min difference you can take. So finally, you will just write min difference equal to math dot min of the min difference which you already have. It means if you closely see, this is what we are doing, right? For initially we will get the min difference as 2, then when you explore other path we get the min difference as 1, so which is less than previous one, so that you will just take that value. So that's how somehow you derive it, so it's not a complicated thing to understand. So once you find out what is the minimum between these two, so find that out, return min difference. Perfect, buddy. So you can return find absolute difference. You are starting from row 0 and sum initially 0 and this is your target and this is your matrix. So that's it. So it works. Now, what are the repeated problems you could see? What are the repeated problems you could see? Can you convert this into tabulation? So what are the repeated problems you see? You know, this problem I didn't solve before. So today only I just looked into it and try to do it. So the thing is, you don't need to worry about, you should be clear about the concept. So what is trying to say? So what is the concept you could see here? From any row, you pick up one cell, then you try to process, right? So that's how you just explore all the possibilities, figure out the solution. Now tell me what are the repeated problems you could see here? Hmm. So in this case, 0 is the absolute difference, right? So you can check if min difference, which is equal 0, then you can return 0. So that's a possible min difference. You don't need to explore any other possibilities so that it will work out. But if you find if there is no 0, right, then you 0 or 1, na? Yeah, 0 or 1 or less than or equal to 1. Oh no, no. When it is 1, there can be possibility of 0, right? So you should see when it is 0, then that's absolute difference you could see, so you can return 0. No, no, if you could only see what are the parameters we are taking in. So these are only two parameters, right? My recursive function is considering these are only the two parameters, right? What are the changing parameters in my recursion? So these are only two, right? Correct? So here, when it comes here, my row and sum is 1 comma 1, here 1 comma 2, and here 2 comma 4, right? Here 2 comma 5. Don't get confused. 2 comma 5, 2 comma 6. Correct? Correct, nobody? These are the so this is my recursive call actually. These all are my recursive calls. And in the recursive calls, I have derived subcalls. So now if you closely see, what are the repeating parameters you could see? 2 comma 5, 2 comma 5, right? So what does it mean? 2 is representing row number, correct? 5 is representing sum. So this is already been solved. Okay, so 2 comma 5 is returning minimum difference as 0. Again, you are trying to solve again. Correct? So there is no point in solving the same again and again, right? So now it's time for to address that. So now you understand that we need to come up with what is the memorization technique I should go with now? So memorization technique. So DP of okay. So there will be two. Uh, I must and should go with two values. One is representing row, another is representing column. Sorry, row means you can blindly take m. That's a row length. What is the column length now? Do you know that? It's out of the context, right? Because the sum is keep on changing now. This sum is not in your control, right? This sum is not in your control, right? So it's like what is the maximum sum you could get? If you closely see here, the maximum sum, what is the maximum sum we got? 11, right? So how do you get 11 here? Ideally, it should be 12, somewhere between 12, right? If you see here, 12 we got. Maximum sum we got is 12, right? So how do you get 12? I understand, but how do you get 12? How do you understand 12 could be the maximum? From each row max value, right? From each row max value, so 2 plus 6 plus 4, which is 12, right? So what you need to do, you need to, this column maximum sum, you will get sum, right? Sum plus 1 you should consider. How do you derive this sum plus 1? From each row, so max value, then you will sum it up and you will get a sum plus 1. So to get to map to this value, you should be clear about finding out a max value from each row, so it will not lead to array index out of bounds exception. Got it now? So, so these are, if you go with the DP array, this is how you should do it. But if you go with matrix, this hashing, right, then you don't need to worry about this out of bounds map, right? So if you go with map data structure, then there is no out of bounds, right? Here indexers are defined. There you can directly handle with it. Okay, so for now I'll go with the DP. So what I should do first, I need to find out max sum, so which is equal 0. So what should I do? So from each row, uh, integer m equal matrix dot length, integer n equal matrix of. What is the time complexity here? What is the time complexity? Tell me. How many subproblems you will derive? How many subproblems you derive? So if you closely see, I'm having at 0, and from here you will move on to 0, 0, 0, 1. From here again you will move on to 1, 0, 1, 1, 1, 0, 1, 1, 2, 0, 2, 1. Here also 2, 0, 2, 1, and so on, right? So what are we trying to do? How many possibility of yeah, so at max you will have m into n into for each direction you will have a sum, right? Yes or no? So this is your the time complexity. So you will derive definitely m by n subproblems, right? So you will explore all the possibilities. Okay. So actually I noted these ones, but if you think that this is also these are also subproblems only. Okay. For simplicity's sake, I made this way because all these are recursive calls only, na? Yes or nobody? So, but I consider this value and mop. Yeah, so you can, okay. So 1, 0, I consider this value and this is a recursive call. Okay. Whatever we highlighted, those are the recursive calls. Don't get confused. So these are running within a for loop. Okay. So these are the recursive calls. Okay. Uh, so definitely you will, of course, even if you run in a for loop, so you will try to do it for m by n and into sum. So whatever sum you could get. Okay. So let's move on. Uh, or no, this is wrong. Actually, you are deriving a dp, you are deriving a dp of m and sum, right? Yes or no? You are deriving a dp of m and sum, right? So definitely it's not more than that, right? Yes or no, buddy? It's not more than that. So it should be m into sum, right? Clear? But this m, is that clear? The unique subproblems you derive, the unique subproblems you derive is m, right? M into sum, right? Yes or no? That's what I'm saying. So this is a for loop. Within a for loop, it is happening, right? Within a for loop, it is happening. So it's not actual recursive call. If you closely see, within a for loop, it is happening. 0, 1 for a given row. So 0, 1, and you will try to go with that row and the current column. So, uh, so ideally, if you, yeah, unique subproblems you can derive as a m into sum. So that's how you can simply return it. But if you technically speaking, indirectly, yeah, m into n cells we are processing and into sum. But this m into n cell we are always pointing to the row number, correct? Correct, na? So we are always pointing to the row number and row into sum. So we go of m into sum. You even if you say m by n sum, that is also fine uh, because technically we are processing every cell. Okay. Okay. Let's move on. The space complexity is what is the space complexity? So for DP, it is going to be big O of m into sum, max sum, and it is max sum you can say. And for stack, it is big O of m, right? So it will have only m. Okay. So let's do that. Let's go here and find maximum, right? So how do you find maximum? So for each row, okay, so no, no, I'm not doing anything on iPad. So here, let's find maximum here. So how do you find out maximum? For integer row equals 0, row less than m, row plus plus. Okay, so how do you get it? So maxsum plus equal to get max value of a given row for this matrix. Correct, nobody? So I will derive that get max value method. That is not predefined method. We have to derive it. Huh? How do you max value sum of max value? They didn't mention it. Yeah, so I is a value between 70, right? So you can have 70 into the row number, right? Yeah, but it takes more memory. Rather than that, you can do this also. 70 into number of rows. So the maximum value could be 70, right? So you can have 70 into number of rows. Yeah, that is fine. But we can do this way also. So here max value. So max value starting from 0, right? So initially starting from 1. So I'll take it as 0 and for integer column 0, column less than matrix dot length column plus plus. So you can consider max value equal mat dot max of max value comma mat of row column. Somehow you will get the max value. You will just return that max value, and you will get this max sum. So once you get the max sum, it's time for you to design the DP of new integer for a given rows and max sum plus 1. You should do plus 1 because 0 to n minus 1, right? So you should consider this max sum plus 1 so that it will be accommodated. So let's consider it as integer, and this is also integer. Let's go as dp, add this dp. So not here, here. Oh, yeah. Okay, so I am speaking little slow. Okay. Are you not able to hear me? I was speaking low earlier. So see what I'm trying to do, I just moved max value method to the bottom. I just took integer m max sum plus 1. So I just pass the dp and this is a dp variable. And we'll see when the row equal to max, we'll find the absolute difference. Otherwise, we will check whether this dp of row and the current sum is not equal to null. It means which is already been solved. Then simply you can return it. DP of row and sum. Otherwise, what is your job? You need to figure that out. So while calling this method, pass the DP and find out where is it? DP of row sum. Add that whatever difference you could get. So add it to the DP of row sum and return it. Clear? Clear, buddy. There is no additional thing we are doing, right? So I think, do we need to update here? I don't think is needed. So, submit. So that's it. So that's how it works. So it's all about how do you manipulate it. Okay, so in this case, when you go to memoization, right, I feel like how do you represent same code as a matrix? So for example, you don't get a thought of having max sum plus 1. So how do you solve it? So I don't want to use DP array, but somehow I should go with the map. Mm. What is it? Map of? How are you now? If you closely see this DP, right? How is this DP representing? Closely understand how is this DP representing? Assume that sum equal to 10. Okay. Then sum can be 0, 1, 2, 3, 4. Let's say sum equal 5. Sum can be 0, 1, 2, 3, 4, and row equal number of rows all 3. So it can be 0, 1, 3, 2, right? So if you closely see, this is your DP, right? This is your DP array, right? Now if you closely see, you will have cell at each position. You will have cell at each position, right? So this cell is representing 0 with row 0 and sum 4. This cell is representing with row 0, sum 5. This cell is representing with row 1, sum 5. So how do you represent the same concept in the form of map, right? Simple, right? So simple, you have a map, you have a row number, then single row can represent any number of sums, right? Yes or no? So you have again a map. There the key is sum. Value is going to be the absolute difference, right? Correct, na? So you can simply do this way, right? Rather calculating DP array and all. Is this clear? So now let me change this code so that I don't need to worry about finding out all these things because when there is a negative value, right, it is very tough to get the thoughts on the spot. Okay, so I don't need to worry about this MN also. So what I will do, this maximum, all these things not required. So let's closely see here. I'm going to take map of integer. It is representing row and map of integer which is representing sum and integer which is representing absolute difference. So this is my DP. So new hash map. What nothing we are doing nothing. Whatever DP array you are representing, right? So which what is it representing? Map of keys row. Then again you have map of keys sum. Value is absolute difference. Correct na? So now let's move on. We will pass this. So what you should do? You copy this and paste it here. Now earlier you checked not equal to null, right? But this is map na. So how do you know that which is already solved or not? So first this is map, right? So first you will see row present. So first row present, then sum present. Then you will get it. So DP of contains key of row. If row present, then then on that row DP of get of row, you will get multiple sums. It means again it will return this map, right? Sum map. So get of row dot contains key of sum. Correct na? So if it is there, then what you should do, you will just return it. This is not a critical logic. It's a simple thing. Okay, done. So we are done it. So otherwise, what you should do at last, what you should do, so you will store that value. So here we did the assignment, right? So first we will say dp dot put if absent of row comma new hash map. Okay, so it means, what does it mean? So if it is absent, if the row is new, then it will create a new entry. Then what it does, then it will simply get dp of get of row. So it will return the sum map. So this is my sum map. Okay, so for that sum map, I'll just have put of this is my sum, and this is the absolute difference I got. Understood, buddy? Got it? So done. So you don't need to worry about all those calculations. Same logic I applied in yesterday's class, but I went little quick. See, it doesn't require, right? So let me, is it running? Yeah. So it was giving time limit out of bounds exception. Why? Why? Let's look at that. Mm, Somehow we were missing. We are trying to solve same problem again and again. So which is letting into time limit out of bounds. Row is present and row column also present, then you will get row and column. This is absolutely fine. I think when it is returning 0, we are keep on solving it. Uh, okay, I'll refactor it. So I thought of doing this. I think for 0 we are keep on solving. Let me have we taken this test case. Okay. Yeah, that's the problem, man. So did you understand the problem? Is it giving same issue again? Why? When I run it as manual, it is working. I think this is not the issue. DP of row, put if absent, row with the hash map, it's fine. Uh, why it is leading to out of bounds? Maybe this login is causing the issue. Let's take the input size. No, input size not greater than. It is always less than 70. So input size is not a big deal. M to the power n to the power 70 into log n. Is it causing the issue? Maybe what I'm thinking is it's a hash map, right? So to identify the key, if it is a bad hash, if the input is really bad, it will take log n. Maybe that log n is causing the issue here. I think, do you see any change here? I don't think, right? I don't think. So we will go here. Even that case also, we will compare row and column, then get it. Yeah, somehow this is giving time limit. I feel the input size is really huge. Uh, so they are going really huge, right? So it's like m by n 2 to the power of to the power 70 into log n. So probably that is causing the issue. Okay, so it's okay. I think we have left with only one option. The only advantage we get here, the only advantage we get through DP array is it's constant time, right? Finding the cell is constant time, right? Yes or no? But here, the finding the cell is not going to be the constant. Definitely, it is going to be log n in worst case. So even the log n doesn't matter here because the number of elements you could have max is 70. Any issue you could see here? You give a try on it. I don't see any flaw in the logic, but somehow overall time complexity. So when I run it individually, right? If you closely see when I run this test case, so what is happening is they have a time limit for all the test cases. So they'll pass couple of test cases, right? So all the test cases should be executed within the time limit, less than a second or so. In this case, when I run it manually, right? So there are only four test cases, so that which is executing less than the time limit. But when they are running actually, if you closely see the previous submission, right? When they are running, they are submitting around how many? 81 test cases. So out of 81 test cases, overall time is taking more than expected time. That's why it was giving time limit. Got it? Understood, buddy? Understood? You give a try. I think there is no option for us, but still this should be valid solution with respect to the map. The only concern is which is taking log n time for identifying the element. That's how which is going into, so which is like m into sum into log n. So that log n is causing the issue. I feel that is the issue. You can give a try. Okay, that's it. So let me look at the other problem. We will at least give a brute force solution, then you can try for, yeah. So this is unbounded knapsack. We were looking at to, right till now what we did, so we discussed about bounded knapsack. So in a bounded knapsack, how the things works out? In a bounded knapsack, how the things works out, buddy? Or you don't need to take the element, right? So this is the problem in unbounded knapsack. So unbounded knapsack means how does it work? Include and exclude. For example, you have element 1 and you have a target. So first you will consider element 1. In earlier case, you will consider or you don't consider, you will move on to element 2, right? So in this case, what we see, we will repeat the same. So I'll consider element 1 again. Let's see, is it possible with the target? And again, I will consider element 1. Is it possible? If it is not considered, then I will move on to element 2. Got it? So, so I keep on considering the same element until I reach to the base case. So then only if it is not possible. So there are two cases. In the earlier include or exclude, it's a bounded. So it means you can choose element only once. But in this case, it is unbounded. So in a unbounded, you can choose the element any number of times. So any number of times. So that's what the problem statement says. Now let's move on. Let's talk about, let's see the input. So you have, what is the problem statement saying that you have, you will be given a coin change 1 to 5. All are, these are the coins, all are the denominations of the given amount. Okay, so given amount which is 11. It means, so you need to find out minimal coins required to the target amount. How many minimum coins required to the target amount? For this, in this case, for example, I can take 11, 1, 1, 1, 1, 11 times, then which is equal to 11. I can take 2 5 times, 2 5 times, then 1 1. So which is equal to number of coins here is 6, right? Coins are 6, right? Number of coins are 6. Then I can do the optimistic way I could directly go is I can have two fives and one one, so which is equal to 11, and number of coins I took, so number of coins I consider is 3. So this is the minimal coin. So I need to return minimum coin required, so which is equal to 3. Clear? So how do you solve it? How do you solve it? So yeah, so as the input is taking really larger, so 1 5, what am I tell you? Call అమ్మా, call. వద్దులేనమ్మా, వెళ్ళమ్మా. నేను ఒక 10 minutes లో వచ్చేస్తాను. 1 5 and what is it? 1 2 5, right? 1 2 5. Uh, let's target amount is 11, right? So let me try for I don't. So I'll choose one. I'll choose one 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 11 times, right? Correct? So one and one and so on and so on. 1 11th time. So which is reaching to the target. So it is returning the value as 11. Correct? Correct? So this is I'll explore one possibility. So just for so I'll explore one possibility. So let's I don't explore all the possibilities because which is really taking long regression tree. So let me go. So I'm at one. So from one, I'll choose one. Okay. Okay. Let me take somewhat minimal input so that things will be smoother. Let me take somewhat minimal input so that I can explore all the possibilities. Amount equal to 4, buddy. Okay. So what are the minimal coins you require to make amount 4? 2. So you can take 2 times. So which is output is 2, right? So let's see how do we derive it or not. So first I'll consider 1. Again I'll consider. Again I'll consider. Again I'll consider. If you closely see in this direction, so once I consider 1, okay, closely understand. So you will have 1 here. So initially the sum is 0. You consider 1, so sum is 1, and you consider 1. Oh, understood. Wait. Sum is 2 here, and you consider this one, sum becomes 3 here. Then again you consider current one. Again you consider this one, so sum becomes 4. Correct? Sum becomes 4. Now if you closely see, sum is 4. Sum is 4, right? So each time what you do, so it is going to be 1 plus 1 plus 1 plus 1 plus. The depth, right? The depth you calculate is 4. Correct, nobody? The depth you could see this is 1 2 3 4, so that the depth you got as 4, so that obviously you can definitely consider 4 coins here. Okay, so you got 4 coins. Okay, so let's look at other possibility. నాన్న, class చెప్తున్నా. So let's look at other possibilities. Okay, so I consider this one. If I don't consider one here, so if I don't pick one here, then what should I do? I will not, I will go for other end. I'll go for other end. So definitely I will move on to next element 2, right? Yes or nobody? If I go on to next element 2, so sum becomes 5, right? Yes or no? So which is greater than 4? Which is greater than 4 for sure, correct? So definitely you couldn't find any direction so that you can skip it, correct? Because all are positives nobody. So if you get greater here, definitely the bottoms definitely greater, right? So you don't need to explore. Yes or no? So definitely you will return max value here because you need a minimum value, right? You need a minimum sum, so that I will return max value. Here it is returning 4, here it is returning max. So that the minimum of these two is going to be 4, so that this will return 4 to the caller, correct? This will return 4 to the caller. Now let's look at other possibilities. So I am here. So definitely I will go on to next direction. If I go on to next direction, I'll go with 2. So that if I go with 2, here the sum is 2, right? So if I go with 2, so definitely the sum becomes 4. So again, which is 0, right? Which is 0, nobody. So it means which is reaching the target, right? Yes or no? When you are moving here, whatever sum you carry here, just add to that. Okay, so don't get confused. Okay, don't get confused. You see the number of coins we chosen. So one, two, three. So the number of coins we chosen is three. So that you will definitely return. Uh, okay, so here sum is 4. So the number of coins we chosen is 3. So we already calculated sum 4. So sum 4. So the number of coins we chosen is 3. So that from this direction, if it is returning 3 and it is returning, so from here, if you go inclusion, so you get 4 coins. If you go exclusion, you get 3 coins. So that obviously this is returning to this as 3, correct? Minimum of these two, na? Minimum of these two, so which is returning 3. So now let's move on. Now let's move on. So now you are here. So here the sum is 1. So you will move on to 2. Then sum becomes 3, right? Sum becomes 3. Now again, you have two possibilities. So I can include or I can exclude. If I include 2 again, then sum becomes 5. Sum becomes 5. So which is greater than target, so that you will return max here. Then if I exclude, so you will reach where, buddy? So you will reach to the next element, which is 5. Okay, so here you got same sum will be carry forwarded. So when you exclude, you are not adding any element, so that you don't add this element, so the same sum will be carry forwarded. So definitely, if you closely see here, if I include, if I include, I will reach to the end, right? So if I include, definitely, which is going to be 8, which is going to be 8, so which is greater than max, so I can definitely return max. And if I exclude also, if you closely see, if I exclude also, if I exclude also, the sum remains 3, and I will reach to the out of index, right? Yes or nobody? Out of the index. So definitely I can return max here. So that out of the index, and this is not equal to target. So if it is equal to target, then I could have think about it. Then altogether, which is returning max, and this is also returning max. So it means, what does it mean? If you closely see, if you take one, then if you move on to two, then you don't find a solution. So there definitely it will return max. In one direction you got 3, in other direction you got max. So that finally from here, with this solution, you got value as 3. So what you did till now, what you have done? One, you included. You didn't done for exclusion, correct? Yes or nobody? You have done for only inclusions. You didn't do for exclusion, right? Mhm. Let me minimize this. Now let's move on to other direction. Okay, so let's move on to other direction, so things will be clear. So with inclusion, once you include one, so that's the optimistic result you got, which is 3. So let's go further. So let me exclude it. So okay, so now I'll exclude it. So once I exclude it, you will move on to the next element. So definitely, which is going to be the 2, and the sum will remain 0, right? So when you exclude, you don't add this value to the sum, correct? Yes or nobody? Akash, are you following? Okay. So now again same thing, same process. Same process repeats. Sum becomes 4. Okay. Sum becomes 4. Now, if you closely see, the number of inclusions you have is 2. Just a second. Number of included are 2. So, definitely this will return, which is reaching to the target 4. So, this will return true. And if you exclude, you will reach to the 5. You will reach to 5, but once you will reach to 5. I'm not drawing this diagram. So, once you include 5, definitely which is out of the bounds. So, that definitely which will return max. The minimum of these two is going to be 2. So this will return 2, and so the minimum of these two is definitely 2, so 2 will be returning here. So when you go back, if you exclude here, so definitely you will move on to the next element, which is 5. Either you include or exclude, you will reach to 5 or out of index. So both of the cases you will definitely return max here. So definitely you will get max here. So the minimum of these two is going to be 2, so 2 will be returned here, and the minimum of these two is 2, so that we need to return 2. Clear na? Understood? Now the only thing is, how do you manipulate this count? How do you know the count, right? How do you know the count? So which is a critical part. Yeah, you can take it as a parameter and handle it. So it's up to you. How do you want to do with it? Uh, so let me make it somewhat more cleaner. So you have 1, 1, and 2, and 5. So let's take target amount equal to 2. So definitely what I will do is, so I'll consider index. So this is my recursive call. I'll consider index, and I'll also consider the counter, coin counter, and I'll also consider my current sum. I'll also consider target sum. Okay. So in this case, initially when I start, I am at index 0. I am at the counter is initially 0, and sum is also 0. The target is 2. This is clear, buddy. This is index. Correct? Clear, na? So I want to know the counter, right? So minimum coin count, right? So I want to know the minimum coin count. That's why you can use it. So let's move on. Or you can either you can return the coin count as a return value. It's up to you. Yeah. So that is also good idea. So let's take counter as a parameter so that it will be easy for us to understand. So you have 0, 0, and target equal to. Now include, exclude. So when you include, what will happen? You will move on to same index, but counter becomes incremented by 1, and target is nothing but at index 0 you have 1, right? So target becomes 1. Correct? Correct? So again you move on. When you include, again you go on to same index, counter becomes 2, and target becomes 0. So as the target becomes 0, now if you closely see, our target is 0, right? Our target is 0, so you will blindly return the counter. So you will just you will blindly return counter, correct? Correct, nobody? So here the counter is 2. So that's how you can handle the counter. Otherwise, it will be tough to manage. Okay, if I exclude, let's move on other direction. Let's move on. If I exclude, okay, so this is my exclude. So if I exclude, there is no change in the, if I exclude, what I will do, so I will move on to the next index, right? Yes or nobody? I'll move on to the next index. There is no change in counter, there is no change in target, correct? As I excluded, right? Now at index 1, again you do the same process. Again you do the same process. So include, exclude. If you include, you will move on to the same index and counter becomes 2. Target is it is, let's take, don't take two ones, only one. Okay, so target at index 1 you have value 2, so target becomes negative, right? So now negative 1. So as the target is negative, so definitely you should return max, correct? So if you exclude also, what you do, you will move on to the, once you exclude, so what will happen? You are excluding here, so what will happen? You will move on to the next index, counter becomes same, target becomes same. Now again same process, again same process. So if you include or exclude, if you include, what will happen? So you will consider this 2, you will move on to third index with the counter 2 and -4 is the result. If you exclude, you will move on to the next index. Sorry, you'll move on to the same index. If you include, then target becomes negative. If you exclude, you will move on to the next index, counter becomes 1, target becomes 1. Now if you closely see, in this case, here the target is negative, so that you will return max. Here, which is reaching out of index, here also you return max. So altogether this will return max. So if you closely see, this will also giving max and this is also giving max. The minimum of these two will be 2, so that this will return 2. Correct na? Correct na, buddy? So don't get confused. I'll not add this. So this is also max. Okay. Yeah. So the minimum value between these two, right? It's not mean difference. We need to find out minimum value. So minimum count. So here the minimum of 2 comma max is 2, right? So that this will take 2. So it means you can consider, if you include one, you get 2 coins. Okay, so if you include one, so this will return 2. Okay, so in this direction you got completely 2. Now if you exclude, so what will happen? Closely see, if you exclude, so this is more important observation. Now I am excluding it. Okay, so let me, so we have done with include. So let's go with exclude. So you will go with what, buddy? You will go with index 1 and there won't be any change in counter, there won't be any change in target. Now at index 1, you include, index 1 value is 2, right? So it means as you included, you will move on to same index, counter becomes 1 and target becomes 0. Now if you see target is 0, so you will return the counter, so the counter is 1. Now if you exclude, then what will happen? So there won't be any change. So you will move on to next index, there won't be any change in the counter, there won't be any change in the target. Now again you include or exclude. If you include, you will move on to the same index. Counter becomes 1, target becomes -3 because value is 5, right? Or if other case, what will happen? You will go 3, 0, 2, right? So in both the cases, which is out of index and this is negative, so it will return max, it will return max. So this will have max. Now, if you see the minimum between 1 comma max, which is 1, so this will return 1 and this will return 2. The minimum between these two is 1, so that we will return 1. Clear? So that's how it works. Let me quickly write it. So probably tomorrow we will talk about time and space, everything. Uh, Min coin count. So if index, which is equal to coins dot length, we know that this is the base case, right? Yes or nobody? This is the base case. So what you do, so we also take a counter, right? So integer count. So one thing for sure, so if if your amount which is equal to 0, so you can simply return the counter. Hey, not 0, counter, right? Whatever counter you have, coin counter, right? That's what we did now. Why are you confusing? You see, when the target becomes zero, when the target becomes zero, we return the same counter, right? That's why handling that counter only we took it in the variable. Okay, so we return the counter. If index equal coins dot length, then definitely you will return integer dot max value. In what is the other case? What is the other case? We will return integer dot max value. So either amount less than zero also we will return integer dot max value. Correct? Here the amount means target. Okay. Let me take it as amount only. Okay, fine. So otherwise, what is our job? What is our job, buddy? So, so we need to find out min coin count. So what is our job? So we will keep on include so min coin count. Okay, so min coin count of coins, comma amount minus uh, current coins of index. It means what? It is including, right? Yes or no? So if you are including means counter plus one, correct? With the same index. So we will go with the same index. Clear? Then we'll also find out exclude. So if you exclude, there is no change in amount, there is no change in the counter, but we will move on to the next index. Correct? So we need to find out minimum of these two, right? Yes or no? This is include count. This is exclude count. So we can return math dot min of include count comma exclude count. So return min coin change of coins starting with the same amount, starting with the zero index, zero counter. Perfect na? Yeah. So there is a case. The case is what is the case is if there is no matching found, right? For example, you have one and you got three, but you can't make coins, right? In that case, we need to return minus one. So understood. So we need to return minus one. So definitely, if there are no matching founds, right? So definitely, which is equivalent to integer dot max value, correct? So which is equivalent to integer dot max value. So then you will return minus one. Otherwise, you will just return coin count. So that's it, buddy. So uh, now, can you think about what are the repeated problems here? What are the parameters which are frequently changing? And index, right? So, but if you closely see counter, we will hold as a result, right? At the end, counter we will hold as a result, right? So only the change is index and amount, right? So what is the maximum amount I could have? Correct, na? So total sum of coins, right? So that what I'll do, I will just take an integer dp. So new integer, let me finish it. So integer total amount. So which is going to be arrays dot stream of coins dot sum. So it will return the total sum so that you will get that. So integer dp new integer. So definitely it is going to be coins dot length and you will also have total amount plus one. Correct? So you will pass this dp here. Where is that method? It is gone. Okay, somewhere here I written. So you will pass the dp here. So okay, so dp done. So you will pass same dp here. What is your job? If here we'll check if dp of row, or what is that, row index, right? So index and amount not equal to null, return dp of index amount. Perfect. Otherwise, what you do, so you will just store this value into dp of index amount and return it. And here you will pass dp, and here also you pass dp. Perfect. Understood. Kalyan Akash. Huh? So here the time complexity, obviously what it is saying, array index out of bounds exception of 11. Oh, got it, got it, got it. The problem is you repeat the same element nowadays. So the amount can be more than that, right? You repeat the same element, right? So it's not just sum. What is it? Amount is up to 10 to the power 4. Okay, so let's do that size as directly 10 to the power 4. So 10 10,000, right? So amount is up to 10 to the power 4. So because you repeat the same element, right? And the value is up to, okay, so it's more than that. It's not something you can do with DP array. So better I will handle with map. Fine, I will handle with map. Same thing. So this is index, and what I'll have, this is my amount, and this is a counter. Because which is reaching out of the thing, right? So which is reaching out of the bounds. New hash map. What happened? Okay, so I'll just handle with map. So what I'm trying to do, so we'll have map of. I think we can find out somehow the math equation, but as the time is a constraint, you have map of index, comma map of amount, comma counter. So this is what we are trying to do it. So let me make it quickly. Same thing. What we do, so first we will check dp of contains key of index and dp of get of index dot contains key of count amount. Then simply we will just do dp dot get of index dot get of amount. Okay, so this is simple thing. Then what else you can do? Here you can update it. So dp dot put if absent of index with new hash map, and dp dot get of index dot put of amount with this difference. Okay, so I think this should solve. Let me try. Where is this? Somewhere we are doing mistake, man. Is there any mistake we are doing? Okay, we'll see this tomorrow, man. I need to drop my kids. Probably we'll look this in tomorrow. Maybe some mistake we did. We'll check that. Okay. Yeah. Bye. వదిలేస్తున్నాను.